annual income versus years of schooling, fitted with a regression line. One person with only a few years of schooling has an exceptionally high income compared to others. Such a data point that does not follow the trend and is far away from the regression line in the vertical direction is called an outlier. Quantitatively, outliers can be identified using residuals, which is the difference between the observed y-value of the data point and the y-value as predicted from the regression equation. Now, the standard deviation of the residual is calculated using its formula. As a rule of thumb, data points located at least 2 residual standard deviations above and below the regression line are flagged as potential outliers. In addition, data sets may also have influential points. These points are located horizontally, far away from the rest of the points. The addition or removal of the influential points significantly changes the regression line. Consider the weekly data for the number of positive results versus COVID tests during the pandemic. A regression line drawn on the scatter plot shows a linear trend between the variables. Whether this regression line is the best fit line is determined using residuals, the vertical distances of the original data points from the predicted values on the regression line. For example, for the data point with coordinates 820 and 48, the predicted value can be found by substituting x with 820 in the regression equation. The difference between the observed and predicted values gives the residual value. Similarly, residuals for the remaining data points are also calculated. The square of these residuals can be visualized by drawing square areas using the original point. The sum of the area of all these squares must be a minimum for the regression line to be the best fit line. This is called the least squares property. For any other straight line, the sum of the areas is higher, hence cannot be considered the best fit line. Consider the weekly data for the number of Consider the scatter plot of airfare versus crude oil price per barrel fitted with a linear regression line. Here, the residual is the difference between the y-value of the data point and the predicted y-value from the regression equation. If these residual values are plotted against the x-value, the crude oil price, the resulting graph is called the residual plot. This plot helps in deciding whether the regression equation is a good model or not. As there is no obvious pattern other than a linear pattern in the residual plot, the regression line is a good fit. Any other pattern, which is nonlinear, indicates that the regression equation does not qualify as a good model. For example, predominantly positive residuals in a certain range and negative in others indicate a nonlinear trend where a linear regression equation is not a good fit. Also, a thickening of the residual plot, as it is viewed from left to right, indicates that the regression line is not a good model. Consider the scatter plot of airfare versus crude oil price per barrel. In an uncorrelated data set, for a given value of x, the best predicted value of y is the mean. If the variables have a linear correlation, a y-value can be predicted by substituting the x-value in the regression equation. The vertical distance between the predicted y-value and the sample mean, y-bar, is known as the explained deviation. The relationship between the two variables can explain this deviation. The vertical distance between the data point and the predicted y-value is known as the unexplained deviation, or the residual. The relationship between the variables cannot explain this deviation. It may be due to chance alone or the involvement of other variables. The sum of the unexplained and explained deviations gives the total deviation. Squaring the deviations and summing them for all data points yields the amount of unexplained, explained, and total variation. The ratio of the explained variation to the total variation is the R-square value, also known as the coefficient of determination. It indicates the proportion of the variation in the y value that the regression line can explain. In an uncorrelated dataset, the interval estimate of any variable is known as the prediction interval. It helps decide if a point estimate is dependable. For example, consider the scatter plot of profit versus investment of a company. These two variables are positively correlated. The predicted profit for an investment of $920,000 will yield a single value, a point estimate of the profit. A serious disadvantage of having a point estimate is that it does not contain any information about the accuracy of the value. So, a prediction interval is used to estimate the range within which this y value might lie. The prediction interval depends on the standard error of estimate, a collective measure of the spread in data points around the regression line. A lower SE value indicates data points closer to the regression line. The standard error of estimate is used to calculate the margin of error, which provides the prediction interval for the y value. The interval estimate of multiple regression is a statistical tool used to analyze the relationship between more than two variables. Multiple regression can be modeled into a simple equation that estimates the linear relationship between the response or dependent variable, with more than one predictor or independent variables. For example, the water consumption of athletes is positively correlated with both the temperature and the total amount of time practiced. Here, the temperature and the total amount of time practiced are the predictor variables that can be independently set. The water consumption is the response variable, as it depends on the other two variables. Since the manual calculation of the multiple regression equation is generally complex, software is used to solve it. The multiple coefficient of determination is calculated to measure how well the equation fits the dataset. It means that the changes in temperature and the total amount of time practiced can explain 97% of the variation in water consumption. However, as more variables are used, R-square generally increases. In such cases, the adjusted coefficient of determination is calculated, which accounts for the sample size and the number of predictor variables.